Imagine stroking a fingertip and instantly feeling the warmth of the sun, the texture of a leaf, then flip to a robot's hand doing the exact same thing. In a London area lab, UK scientists have grown a synthetic skin that comes much closer to feeling like human skin could. This is the next frontier for prosthetics, robotics, and the boundary between biology and machines. For decades, engineers have built robots and prosthetic limbs that can move, grab, lift, but one thing remained elusive: touch. Real human skin doesn't just detect pressure, it senses temperature, texture, even damage. Most artificial skins use arrays of separate sensors, one for heat, one for pressure, one for shear. These systems are complex, expensive, and often fragile. A team at University of Cambridge and University College London asked, can we make a single material that behaves like living skin, sensing many different stimuli at once? Their solution? A soft, stretchy, electrically conductive hydrogel made for the surface of a robotic hand. The material is poured, molded into the shape of a human hand, and placed like a glove onto a robotic limb. What makes it special? The entire skin acts as one sensor, not dozens of individual ones. Inside the gel are hundreds of thousands of tiny conductive pathways or channels that respond differently depending on whether you pressed it, warmed it, stroked it, or cut it. The team wired only 32 electrodes at the wrist of the hand model. From there, the system captured over 1.7 million data points across the skin surface to learn what kind of contact it was feeling. And they even subjected the synthetic skin to harsh tests: a heat gun blast, a scalpel slice, and the skin still registered different types of touch. According to Dr. David Hardman and Dr. Thomas George Thurethel, the goal was to detect multiple types of touch at once, but in a single material. So why is this so big? First, for prosthetics, a person with a robotic limb could someday feel the difference between holding a delicate glass or a hot mug of coffee, reducing accidents, increasing confidence and connection. Second, for robotics more broadly, machines working alongside humans in factories, disaster zones, or homes will benefit from skin that senses not just contact, but what kind of contact. Is the surface hot? Is it sharp? Are multiple contact points involved? The new skin can distinguish those. Third, from a material standpoint, it's relatively low cost, durable, and easy to manufacture compared to older multi-sensor systems. The boundary between human and machine is shifting. The question, can a robot feel, is no longer just science fiction. But there are caveats. The researchers openly state that the synthetic skin isn't yet as sensitive as human skin. Durability in real-world conditions, long-term use, and integration into prosthetic or machine systems remain to be proven. The team is working on enhancing robustness, scaling up manufacturing, and testing the skin in realistic robotic tasks. Meanwhile, ethical, social, and design questions will follow. When machines can feel, what responsibilities do we have toward them? And for prosthetics, how do we translate sensation into meaningful experience for the human user? From a simple tap to a complex texture, from warmth to damage, the sense of touch is elemental. With this breakthrough from UK scientists, we move one step closer to a future where machines can truly feel and humans can regain lost sensation. Subscribe for more breakthroughs at the frontier of biology and technology, because the future isn't just coming, it's feeling.